Hi everybody, how are you? I hope you're well. Today I'm going to solve two exercises from an SAT exam. I'm going to focus in the topic of polynomials, in the topic of algebra. So we're going to solve two exercises. So here we go. Let me shrink my face a little bit and we will start. Okay, here we go. Let me grab the first example here. So here is the first exercise. Okay. So we start with this problem. We have this polynomial 2 times x cubed minus k times x minus 3. And the problem says that x minus 3 is a factor of this polynomial. So this is the factor. We notice that this polynomial is polynomial of degree 3. And this is degree 1 because it's implied here, is implicit. So we will need a polynomial of what degree? We will need a polynomial of degree 2 in order to obtain a polynomial of degree 3. So we put a general polynomial a times x squared plus b times x plus c, a general polynomial. So here are many approaches that we can take. The approach that we are going to take, we are going to expand this expression here. We're going to expand it and we're going to compare to the original polynomial here. This is our original polynomial. We will compare coefficients and we will find all the variables that we need, a, b, c, and the variable that we are interested in, which is k. So we start multiplying here. X multiplies all the polynomials, so we have a times x cubed plus b times x squared plus c times x. Now the 3 multiplies 2 minus 3ax squared minus 3bx minus 3c. Now we reduce a little bit this expression. Here we have x cubed. There is no other x cubed, so we have a times x cubed plus we have x squared here, b minus 3 times a x squared. We have x here, we're going to put it here, x here, so plus c minus 3 times b x, and there is only one independent term, which is minus 3c. And our original polynomial was 2 times x cubed plus 0 times x squared minus k times x minus 3. So if we compare, I'm going to do it with green here, we have here that a equals 2 by looking, b minus 3a equals 0, so b equals 3 times a, and a equals 2, so we replace the value here, so b equals 6, and we have here that c equals 1, because minus 3c equals negative 3. So we already have the values a, b, c, and we have k here, which is what the problem asks. So we have here, remember to take the sign, so we have here that c minus 3 times b equals negative k. So k equals 3 times b minus c. We replace the values here. K equals 3 times b, which equals 6, and c equals 1. So we have 18 minus 1, k equals 17. So the answer to this problem is the alternative E. So that was the first problem. Now we will do the second one. A new page here, and I have here the problem. Here is the second problem. I'm going to enlarge it. Here we go. Yeah. So we have this problem here. It says that minus 2 minus the square root of 7 is a root of the equation x squared. Let me put the pen here. the equation is x squared plus 4 times x plus 3 times k equals 0. And this is a second degree polynomial of a quadratic equation, and the coefficient here is 1. So this polynomial, if it can be factorized, which it can be since we already know a root, it's x minus the first root, which is x1, times x minus the second root, which is x2. So if we expand this multiplication, we have x squared minus x times x1 minus x times x2 plus x1 times x2. So as we can see here, if we group the terms, we have that the last term here, the independent term here, which is 3 times k, equals to the multiplication of the roots. And also we know that from the general formula, we have general formula, that for a quadratic equation we have that x equals minus b plus minus square root of b squared minus 4 times a times c, all divided by 2a, right? We have here, and let me put a ruler here to put the line. So if we pay attention here to the formula, we have that one of the roots is minus 2 minus square root of 7. So if we pay attention here, we notice that it has a root, the root here and the root here. So we also notice that here there is a plus minus sign, and we have minus here. So the other solution has to be x2 minus 2 plus square root of 7, because checking the formula and given the known root, we can obtain the other root. So 3 times k, for this for the property here, we have that 3k equals the multiplication of the roots, and we already know the first and the second root, so we just have to multiply the roots, x1 times x2, so we have minus 2 plus square root of 7, excuse me, the roots are reversed, x1 is minus and x2 is plus. So we have here the difference of squares, of minus 2 squared minus square root of 7 squared. So this equals to 4 minus 7 minus 3. So we can finally say that 3k equals minus 3 and k equals minus 1. This is one approach that we can take. The second approach also that we have here is that from the equation we already know the here in the original polynomial, we know the factors a equals 1, b equals 4, and c equals 3 times k. And we can replace here in the, let me put another color here, we can replace the values here in the formula. We can replace the values like we're going to do it here very quickly. We have that x equals b equals 4, right? Minus 4 plus minus square root of b, 4 squared, minus 4 times 1 times 3k. Excuse me. I'm going to write it better. Here we go. Divided by 2a, 2 times 1. And we can compare here. Let me put the ruler first a little bit to give it a little bit of better shape. So if we compare the roots, we have x, we have here -2. If we divide the -4 divided by 2, plus minus square root of 16 minus 12 times k. Square root of all this expression, and is divided by 2. Divided by 2. So if we compare here this root and these solutions, because this is x1, x2, we take here the -2 is the same as here, and we have here the minus, we take the minus, so this expression must be equal, the expression here, root of 7 must be equal to all this expression. And if we solve this, we are going to obtain that k equals -1. So there are different approaches to this problem. Both ways are valid. If you remember here the property of the multiplication of roots, it will get a little bit easier, I think. But it is not necessary that you know that property. If you don't know it, or if you forget it, or if you're a little bit nervous at the exam, or you're trying to go fast through the exercises, you just can apply here the general formula and obtain the same result. So that's it. These are two problems that I pick up from an SAT exam. I hope you like it. And if you're interested, if you need some help with math, if you need some tutoring, you can check out my pre-apply profile, or you can contact me through my social media. I will be really happy to help you, and I will reach out to you as soon as I can. Bye bye.